let's see if we can solve this right triangle. And we're only given two sides. We're not given any angles here. So when I'm not given any angles, I mean, only angle that I really know is that I have a right triangle, so I know that's 90 degrees. But I never want to take like sine of 90 or cosine of 90 or tangent of 90. That will only get me into trouble because of the fact that at 90 degrees, cosine is equal to 0, and that always causes a problem. Either something's undefined or it turns up 0. So in order to use the trigonometric functions to find different lengths, I'm going to need to use either angle B or angle A. But how do I get angle B or angle A if I don't have any angles to start with? Well, remember, let's just use, for example, here, the sine function. Sine theta gives us a number. The argument is an angle. The number is the answer. The number being the ratio of two sides of a triangle. Inverse sine has a number as an argument, the ratio of the two sides, and that's going to give us an angle as the answer. So how can we use that in this particular instance here to get at least one of these angles? If I get one of the angles, the other one's easy to get. Well, let's try and figure out what is angle B. Well, the tangent of angle B is going to be opposite, which is side B, 4, divided by adjacent, 7. Remember, SOHCAHTOA, that's our TOA. So I know the tangent of angle B is going to be 4 over 7, and when I'm doing an inverse, all I'm doing is switching the number and the angle. So why not just go tangent inverse of the number 4 over 7 is equal to angle B. Well, let's see if that's going to work for us. Let's make this look just a little bit nicer. I can go inverse tangent of 4 divided by 7. And I find out, well, hey, that's really nice. Angle B is a 29.7 degree angle. So I'm going to put that in right here. 29.74, I'll call it. Well, I know that the two acute angles inside of a right triangle have to equal 90 degrees. So I can go 90 minus 29.74, and that's going to give me 60.26. So this is going to be a 60.26 degree angle. So I've already solved a lot of this here. I found out that angle A is 60.26. I found out that angle B is 29.74. Angle C is 90 degrees. I already knew that. I just need to find the hypotenuse. I can find that using the Pythagorean theorem, or I think I'm just going to use sine. So I'm going to use sine of 60.26 degrees. We know what I already, yeah, I'm going to do that. I'm going to go sine of 60.26 degrees is equal to opposite, which is 7, divided by hypotenuse, which is C. So multiplying both sides by C, these C's cancel out, and I get C times sine 60.26 degrees is equal to 7. And I think I'll divide by sine of 60.26 degrees. Remember, sine of something is just a number. So I can divide by it. I can't divide by 60.26 alone. That's just the argument of the sine function. I have to divide by the whole thing, sine 60.26 degrees. So I get this is equal to C So 7 divided by sine 60.26, 8.06. That's my final side here, 8.06. And that makes sense. It has to be the longest side of the right triangle because it's the hypotenuse. So I'm pretty happy with that.